When a boiler is working properly, the heat produced by the burning fuel will be readily transferred to the water in the tubes. However, there are problems that can interfere with heat transfer. One of these problems is a condition called scale. Scale is the buildup of solid impurities on boiler components that contain water. The boiler's feed water supply may contain impurities. These impurities coat the surfaces, insulate them, and restrict their ability to transfer heat. If the surfaces can't transfer heat to the water, the tube can overheat and rupture. A heat transfer problem can also occur if the feed water supply stops for any reason. Without a continuous supply of feed water, the boiler may boil dry. With no water to remove the heat, the tube metal rapidly overheats and severe damage may result. In boilers that burn coal or oil, another problem that can affect heat transfer is the buildup of soot. Soot's created by ash and unburned fuel particles in the combustion gases. Soot buildup insulates the surfaces, preventing good heat transfer. When this occurs, the amount of heat transfer to the water decreases. As a result, heat is wasted. It escapes with the gases routed out of the boiler, reducing boiler efficiency. The last problem we'll look at is improper warm-up. This may occur if the boiler isn't started up correctly. Water tubes and other metal parts expand when they're heated. If the boiler hasn't been operated for a while, and then it's rapidly heated, its metal parts may expand at different rates, causing some parts to bend or break. To protect the boiler, heat must be applied gradually to ensure that all the metal components expand at the same rate. In this topic, we covered heat transfer. We looked at the major types of heat transfer, and we saw how heat transfer occurs in a boiler. We also looked at a few typical heat transfer problems. Now let's try some practice questions. Convection is the transfer of heat within a fluid, that is, a liquid or a gas. It's caused by a mixing action within the fluid. To demonstrate convection, we filled a beaker with water and set it on a hot plate. We'll also add some dye to show the mixing action. As the bottom of the beaker heats up, the temperature of the water closest to the bottom increases. As the temperature increases, the water becomes lighter or less dense, so it flows upward. The warmer water mixes with the cooler water near the top of the beaker, and heat transfer occurs. As the outer surfaces of the tubes absorb heat, conduction heat transfer occurs. Heat is transferred from the outer surface to the cooler inner surface. Then heat is transferred from the inner surface to the water flowing through the tube. In boilers that burn coal or oil, another problem that can affect heat transfer is the buildup of soot. Basically, fire tube boilers route hot combustion gases through metal tubes. The tubes run through a shell filled with water. Fire tube boilers vary in design, but most operate under similar principles. The combustion area for this one is here. A group of horizontal fire tubes routes combustion gases through the boiler. There's also an outlet for the gases, a feed water line, and a steam outlet line. During operation, water enters through the feed water line. The water level is maintained above the fire tubes to protect the tubes from overheating. Fuel and air enter the combustion area. The burning fuel transfers heat to the water in the shell. The hot gases flow through the fire tubes, and additional heat is transferred to the water surrounding them. Each time the gases are routed through the shell, it's called a pass. The gases pass through 2 times in this example, so it's a 2-pass boiler. The combustion gases flow out of the boiler here in this example. As the water in the boiler is heated, some of it turns to steam. The steam-water mixture is lighter than the cooler water in the boiler, so it tends to rise. Steam collects above the water level. Then it flows through the outlet and into the plant. The feed water, which is cooler and heavier than the steam-water mixture, flows to the bottom of the boiler. It's heated in the combustion area, and the cycle continues. Generally speaking, water tube boilers use tubes to route water and steam through the boiler. The combustion gases flow past the outside surfaces of the tubes. Let's examine this principle in more detail. Water tube boilers may vary in design, but most of them operate in basically the same way. This particular boiler consists of a series of water tubes and two drums. The drums distribute water to the tubes. The water tubes connect the drums and form a wall around the combustion area of the boiler. This is where heat is generated. Water is fed into the upper drum through a feed water inlet line. The water tubes and the lower drum are completely filled with water. The upper drum is only filled to a certain level. This provides space for steam to collect, so the upper drum is often called the steam drum. As fuel is burned in the combustion area, heat is transferred to the adjacent water tubes. The combustion gases then flow out of the boiler. Water circulates from the upper drum through the water tubes and into the lower drum. The lower drum is often referred to as the mud drum. From the lower drum, the water is distributed to the water tubes surrounding the combustion area. As the water in the tubes is heated, a steam-water mixture is produced. The steam-water mixture enters the upper drum. The steam is separated from the water and routed through the steam outlet and into the plant. In this topic, we looked at the two main types of boilers, fire tube boilers and water tube boilers. We saw basically how they're designed and how they operate. At this point, let's try some practice questions on fire tube and water tube boilers. Basically, fire tube boilers route hot combustion gases through metal tubes. The tubes run through a shell filled with water. Fire tube boilers vary in design, but most operate under similar principles. The combustion area for this one is here. A group of horizontal fire tubes routes combustion gases through the boiler. In a water tube boiler, as the water in the tubes is heated, a steam-water mixture is produced. The steam-water mixture enters the upper drum. The steam is separated from the water and routed through the steam outlet and into the plant.